Hey everyone, let's walk through task 1 together. I want to make sure you have everything you need to write some really fantastic answers. Okay, first things first. Before you even start writing, you've got to read sections 9.5 and 9.6 in your textbook. Seriously, this is going to give you all the background info you need. Don't skip it. All right, ready to tackle this? Let's just dive right in. We're going to break down each question one by one, so you'll know exactly what to do to build a really strong answer. Okay, let's get started with question 1. This whole thing really comes down to one important idea: non-renewable. If you get this, you're well on your way to understanding nuclear fuel. So what's this question really asking? It's basically saying, hey, we don't burn uranium like we burn coal, so why on earth is it called non-renewable? It wants you to explain what that word means and, even more important, why that little fact matters for our energy future. Right, so the key thing to remember here is that non-renewable just means it's a resource from the Earth, and there's only so much of it. Once we use it up, it's pretty much gone. We can't just make more. That's the whole idea. Okay, now check this out because this is super important. On the left, you've got a weak answer. I mean, it's not wrong, but it's just too simple. The strong answer on the right, that's what gets you the full marks. And why? Because it does two things. It explains why it's non-renewable, and then this is the key. It connects that to the bigger picture of long-term energy planning. It answers the whole question. So, if you're kind of stuck on how to begin, no worries. You can use these sentence starters right here. They're just there to help you get your thoughts organized and get the ball rolling. Awesome. Let's move on to the second question. This one is all about a really big topic: safety and radiation. So for this one, you need to put on a new hat. You're going to pretend you're a health and safety officer. Your job is to pick which of the 3 types of radiation, alpha, beta, or gamma, worries you the most. And then you have to explain why in really simple terms. This table is a great way to think about it. Imagine alpha radiation is like a big, heavy bowling ball. It's powerful, sure, but it's slow, and you can stop it with just a piece of paper. Then you have beta. Think of that as a fast-moving baseball. It'll zip through paper, but some clothing can stop it. But gamma? Oh, gamma is totally different. It's like an invisible laser beam. It can go right through you. To stop it, you need really thick shields, like lead or concrete. So here's what a top-notch answer looks like. See how it hits all the right points? First, it clearly picks gamma. Then it explains why it's the most dangerous in that setting, because it can travel a long distance and go right through a person. And finally, it nails the explanation with that super simple invisible laser analogy. Perfect. And again, here are some sentence starters to help you frame your answer. Just remember to stay in character, right? You're the safety officer, and your job is to keep everyone safe. All right, on to the final question in task 1. This one is all about time and danger. 2 ideas that are, absolutely at the heart of everything we talk about with nuclear energy. What this question really wants you to do is compare 2 totally different kinds of danger. On one hand, you have something that's super dangerous right now, but fades away. And on the other hand, you have something that stays dangerous for, well, basically forever. So, half-life. It sounds kind of complicated, doesn't it? But it's not, really. It's just how we measure the time it takes for half of a radioactive thing to, well, decay. The pizza analogy here is perfect. Think about it. If it takes 8 days for half the pizza to get eaten, the whole thing will be gone pretty fast, right? But what if it takes 700 million years to eat just half the pizza? Yeah, that pizza is going to be sitting on the table for a long, long, long time. And this chart just shows you how huge that difference really is. You've got iodine-131, it's intensely radioactive, super dangerous in the short term, but then it's gone relatively quickly. Uranium-235, on the other hand, that waste stays dangerous for a length of time that's just hard to even imagine. And that, right there, is the biggest challenge with nuclear waste. So you can use these sentence starters to help you talk about those 2 different kinds of risk. And pay attention to that last one. It's really important. It helps you connect the science part, the half-life, to the massive, real-world challenge of storing this waste safely for thousands upon thousands of years. Okay, you've done a great job getting through those questions. Before we wrap up, let's just quickly go over a few final reminders. These are the things that will really help you get a great score. Now listen up, because this might be the single most important piece of advice I can give you. Please, please, please use your own words. Do not just copy and paste from the textbook or a website. It has to come from you. So why am I making such a big deal about this? Well, it's simple. Writing it in your own words is how you show your teacher what you actually understand. It proves you've learned it. And that's how you earn marks. Your grade comes from showing your own understanding, not from copying someone else's. That's why putting things in your own words is so critical for getting a high score. And hey, just a quick look ahead to task 2. You're going to have to draw a diagram of a reactor. Don't stress about making it a beautiful piece of art, okay? Just focus on making it simple and clear and label every single part correctly. Clarity over artistic talent, for sure. So, think about that as you start writing. What's the one thing you learned today that makes you feel more ready for this? I really hope this helped. You've totally got this. Good luck!